So in this demo, we're going to look at collisions, specifically in 2 dimensions. So we have this table that has little holes where air can get through. So it's an air table. When I turn it on, there'll be some air flowing through each of these little holes. And so that produces a surface that has little friction, so then we can deal with collisions that way with minimal friction. So we have this table. We can use that to consider collisions in more than 1 dimension, so 2 dimensions in this case. You can think of this as, say, the y dimension. That corner could be the origin, so positive y, positive x. So you have a y and an x, and you can have initial collisions, initial velocities in 2 different directions and see what happens. So to start, let's think about a collision in just 1 dimension, just in x. So when I have these 2 objects coming at each other, just traveling in the x direction, this one has a velocity this way, this one has a velocity that way, and so when I push it and let go, that 2 objects, they have a momentum, right? As a system, they have some momentum, and after the collision, they should still maintain that same momentum, so conservation of momentum. When the collision happens in just 1 dimension, in the x direction, then that's all you need to worry about. What's the velocity in the x direction in each case? But now what we're going to do is do this in 2 dimensions. So let's say this object only has an x velocity, so negative x, for instance. This has a velocity this way, and now this object will have a velocity both in x and in y. So let's say if they happen to collide right here, right? So let's say we're looking at 2 dimensions now. So as you can see, now you have to consider momentum both in the x direction and in the y direction. So what's the initial momentum of these objects? So this one has a momentum in the x direction, so that has a certain momentum. This has a momentum both in the x direction and the y direction. So what we have to do to figure out what happens after the collision, how they come off the collision, is to figure out, well, we have some initial momentum in the x direction, we have some momentum in the y direction, and afterwards, after that collision, those 2 momenta have to be the same. The x component and the y component still has to be the same. So that's what you see in 2-dimensional collisions. After the collision, it still has the same momentum, but not just momentum in general, specifically momentum in x and y. So you can think of this in real life. Where you might see something like this? It could be a collision of 2 cars, for instance, on the road. What happens if 2 cars going in 2 different directions collide? We can start to understand what will happen afterwards. So that's collisions in more than 1 dimension, 2 dimensions in this case.